Okay, we are now going to look at in terms of part 2. All right, so we're making a key as we're going. All right, we have the reaction between magnesium and nitrogen in this balanced equation. Explain in terms of electrons why an atom of the metal in this reaction forms an ion that has a smaller radius than its atom. Okay, so what is the metal in the reaction? If you don't remember, you should look at the periodic table and remember metals are almost everything over here, plus all these down here are metals. Non-metals is just this little group over here, plus hydrogen. We have metalloids on the staircase, except for aluminum is a metal, even though it touches the staircase. And then we have noble gases over here. But anyway, so we had magnesium and we had nitrogen. So magnesium is here, nitrogen is here. So which one is the metal? Magnesium. All right, so the metal, that's magnesium. Why it forms an ion that has a smaller radius? Well, let's see. When magnesium forms an ion, let's look at its oxidation state. You see that? +2. So let's just represent a magnesium atom right here. And we have in the outside valence electrons, we have 2 valence electrons. When magnesium becomes an ion, since it becomes Mg+2, it loses these 2 valence electrons. When it does that, the size gets smaller. Think about it. It has less electrons. It's smaller. So why, in terms of electrons, is the atom going to be larger or the ion going to be smaller? Okay, so the atom is larger than the ion because the metal, which is magnesium, loses 2 electrons to form the ion. State in terms of the number of electron shells why the radius of a strontium atom in the ground state is larger than the radius of a magnesium atom. So electron shells, what is that? Well, on the periodic table, the period number tells me electron shells. That means all of the elements in group 1 only have electrons in the first electron shell. All of the elements in group 2 have electrons only in energy level number 1 and energy level number 2, or electron shells, and so on. So elements in period 3 have electrons in energy level number 1, 2, and 3. So we're comparing which 2? Strontium and magnesium. Magnesium and strontium. So why is the radius of strontium larger? Because strontium has electrons in the 5th energy level, whereas magnesium only has electrons in the 3rd energy level. Okay, so we could say strontium is larger because it has more energy or electron shells, energy levels. So it said electron shells, so I had to say electron shells. Even though if you answered energy levels, that makes sense, we have to say electron shells. So strontium is larger because it has more energy levels or electron shells. You could have left out the energy levels part and just said strontium is larger because it has more electron shells. All right, let's look at this data table. It says explain in terms of molecular polarity why the hydrogen chloride is more soluble than methane in water. Okay, what is water? Do you remember? Polar. So, because water is polar, anything that is polar or ionic will dissolve in water. So why would hydrogen chloride be more soluble? Well, it is, let's check. So just so I can remind you how to check. We have hydrogen chloride, HCl, okay? Let's look up the electronegativity of these two. H is 2.2 and chlorine is 3.2. So 2.2 and 3.2, subtract them, get 1.0. That means it is polar. We kind of have to get around 1.7 to be ionic, okay? So hydrogen chloride is more soluble because it is polar, and methane is, what is methane? Methane is CH4. So I don't want to do C with 4 H's because it just looks like this. So I'm just going to compare one of those bonds. So we already know H is 2.2. So what is carbon? Carbon is 2.6. So 2.6 and 2.2, that difference is 0.4. That makes that bond non-polar. And it still has symmetry, so the whole thing, methane, is non-polar. Okay? In terms of electrons, the type of bonding between the carbon atom and the nitrogen atom in a molecule of methenamine. So here's the carbon and the nitrogen. In terms of electrons, well, this is a covalent bond. So what happens in a covalent bond? In the bond, the electrons are shared because it's a covalent bond. Now we could be even more specific if we looked up the electronegativities. So electronegativity of carbon, 2.6, nitrogen, 3.0. If we subtract them, 3.0 and 2.6, 0.4, that's non-polar. So we could be more specific and say the electrons are shared equally because it's a non-polar covalent bond. Well, we don't have to get that specific. It didn't ask for it, but you could. All right, explain in terms of atomic structure. So we've got to talk about what the atom looks like. Why the elements in group 2 have similar chemical properties. So I could talk about any group like this, but it asked about group 2. So why do the elements in group 2 have similar chemical properties? Well, there is one thing that determines our chemical properties, and it is the number of valence electrons. And if you look down this group, you will see they all have the same number. So why the elements in group 2 have similar chemical properties? They have similar chemical properties because they have they all have, right, 2 valence electrons. You could have just said the same number of valence electrons, that would work. Explain in terms of electrons why the radius of a potassium ion is larger than the radius of a potassium atom is larger than the radius of a potassium ion. We did a similar question to this before, so let's see if you remember how to do it. So we have potassium right here. See how many valence electrons it has? Just 1. Do you see the kind of charge its oxidation state? It has a charge of +1 when it's an ion. So we have potassium as an atom, its outermost electron, okay? And then we have a potassium ion, and it's going to lose this valence electron. So what's going to happen to the size when it loses that electron? It's going to get smaller. So the size of the ion is smaller because an electron is lost when the atom forms an ion. Okay. All right, now we're onto the back right here. Explain in terms of electronegativity difference why the bond in a molecule of HF is more polar than the bond in a molecule of HI. So I need to find electronegativity difference. And I need H. Do you remember H? 2.2. So H is 2.2. We need F. Do you remember F? 4.0. It's the perfect one. It's kind of funny because an F is the worst grade but the best electronegativity. And I, which is going to be down much further, is 2.7. Okay. So let's do this subtraction. That's 0.5. This subtraction, oh my goodness, is 1.8. So the electronegativity difference in HF is much greater. So therefore it's more polar. In terms of activity, so I got to talk about activity, why HCl reacts with Zn, but HCl does not react with Cu. So this is the activity series, and that is table J. All right, so looking at table J, HCl. So it would be H with Zn and H with Cu. All right, so here's H. Why would it react with Zn and not Cu? Okay, why? Because where's Zn? Zn is higher. So remember, it's going to kick out H and take its place. Cu is too weak. Oh, so sad. Cu is so weak it can't kick out H. All right, so Zn is more active than H2, but Cu is less active. All right, explain in terms of ions. So in terms of ions, why a 10.0 milliliter sample of 0.30 molar ammonium chloride is a better conductor than a 10 milliliter sample of this. Well, same substance, right? Both aqueous, both 10 milliliters. So that's the same. So something else has to be different. But look at this. What's different? What does that big capital M stand for? Oh my goodness, if you don't remember, look here. What does big capital M stand for? Molarity, which is what? Concentration. So why would this be a better conductor? Well, it has a higher concentration. Since it has a higher concentration, it has more what? Ions. So the 0.3 molar solution has a higher concentration. Now this would not be right because what did I not mention yet? Ions, right? The 3 molar solution has a higher concentration of ions. Real simple. Just make sure you mention the word, right? Here's a balanced equation. Explain in terms of bonds why energy is absorbed during this reaction. Now, here's energy. You can see it's on the reactant side, which makes this endothermic. But if I said it absorbs energy because it's endothermic, although that would be correct, it is a wrong answer. Why? Because it doesn't talk about bonds. Okay? So why does energy have to be absorbed in this case? Well, look at what we start with. O2, which is O2. That looks like this. And then it's separated. So why energy is absorbed? Energy is absorbed because bonds are broken. When we break bonds, break it, takes energy. Explain in terms of collision theory why increasing the pressure of gases in a container increases the rate of a reaction. So remember, pressure, when we increase it, so here we have big space. If we increase pressure, we're going to have little tiny space. Say we had 6 particles. Okay. Why would it increase the rate of the reaction? Increasing the pressure decreases volume, so there are more effective collisions. Okay, beautiful. In terms of subatomic particles and energy states, oh good golly, I have to talk about 2 things. How the colors in fireworks display are produced. Well, electrons and energy states fall from from excited state. I think it was going to be worded if I said back to. Fall from excited state to ground state and release energy as light. This can be used in fireworks. It's also used in flame tests. Okay. A scientist makes a solution that contains this much in 200 grams of water at this temperature, based on reference table G. Oh, for Pete's sake, if they say reference table G, turn to reference table G. Okay, so I'm going to get there. It's this one. The substance we have is HCl. So HCl is right here, this one. And I have 44 grams of it, but here's the thing. Here's where you have to be careful. See, I have 44 grams and 200 grams of water. Notice something real important right here. This says 100 grams of water. Yikes. That means I better be careful. So I have 44 grams of HCl in 200 grams of water. But I can't even use the reference table. Why? Because the reference table doesn't have 200 grams of water. How much water does it have? It has 100 grams of water. Okay, so I need to find this. How much HCl is that? What you should realize is this is just half. So half the amount of water. So it's going to be half the amount of HCl. So that's going to be 22 grams of HCl. Now, if it wasn't as perfect of a ratio, that might be harder. But here is where people make a mistake. Do not do anything to the temperature. No, only the grams, because I'm comparing grams to grams. The temperature doesn't change. Okay, you can't like have the temperature. We're not doing that. Grams and grams, if one is, we have to cut it in half, we cut the other one in half. Please do not change the temperature. Oy, good golly, please. Okay. So let's find now. We have 22 grams of HCl and it's at 20 degrees Celsius. Okay, so I'm at 20 degrees Celsius. I'm going to go to 22 grams, which is right about here. Find the line for HCl. So where is this point compared to that line? Is it on the line? Is it above the line? Or is it under the line? Well, it is under the line. So it is unsaturated. The solution is unsaturated. Okay. Explain in terms of the distribution of particles why the solution is a homogeneous mixture. It is homogeneous because the particles are evenly distributed. Perfect. All right, last one. Part of this is cut off. This I added in what was missing, but when I print this, this will be there, so don't worry about it. Explain in terms of intermolecular forces why isomer 2, so that's this one, there's only 2 in the diagram, boils at a lower temperature than isomer 1. You can see the temperatures. Why does it boil at a lower temperature? Isomer 2 boils at a lower temperature because it has lower intermolecular forces. Low forces, low boiling point. High forces, high boiling point. All right, that's it. We finished part 2 of In Terms Of.